Thank you very much, Chris, and thanks to the organizers for inviting me, including taphonomy, on this wonderful symposium. And it was a very nice lead-in, actually, from Jess about the topics I'll be talking about. You'll notice also that this is a slightly different title than is on your program. I decided that I would focus on the taphonomy of Lucy, even though I have really not had the opportunity to study that skeleton in detail. I had a lot of opportunities to study 333, but because those bones and what I was doing with Bill Kimball and Elizabeth Harmon, we have not been able to publish for various reasons yet. I'm going to go with the information that's available for Lucy, but also give you a taste of where 333 might contribute. So Lucy's discovery, as we've been hearing from many people, energized new questions, possibilities in understanding our ancestors and bringing them back to life. Who were they? How were they related? What could they do? All the wonderful anatomical studies. Where did they live? Environments, habitats, faunas, and floras. And my niche in this wonderful enterprise has been to think about how did they become fossils. And I'm really indebted to and standing on the shoulders of the father of taphonomy, who started work in South Africa on the cave deposits. Bob Brain sadly passed away last year after an amazingly long and productive and influential life. And I just wanted to show you this quote that he put into his book. It's a detective story, but a rather odd one because the clues are bones. The aim is to establish causes of death, but the evidence is ancient and there are no witnesses to relate their experiences. And also, he said at that time, in that book in 1981, he found himself in an uncharted field where guidelines were few and ill-defined. So my start in taphonomy was in the early 70s, and I got my PhD on that topic and paleoecology in 1973. And it was from Bob Brain that I got some of my earliest inspiration. So taphonomy, and here is a rather complicated diagram, but taphonomy is complicated. But if you follow from the biosphere to the lithosphere along these lines, you see that each one of the arrows has a filter and a little turbulence, and that is actually representing the fact that you're getting sampling and filtering of the information all the way through this process until you get the buried remains and the fossils, and then you actually still get filtering and human or modern scientists taking some parts of the body, able to recover them and all, before you get back to your reconstruction of the biosphere, whatever you want to know. So ecology is a lot of what we need to be aware of, what's going on with the remains before they become buried, but geology is also a very important part of the whole realm of transition of biosphere to lithosphere. So what I'm going to do in this talk is chart a pathway that starts with what we know from the geology, the buried remains that were found actually on the surface, not in situ, and talk about what the evidence is there, and then what the bones show us about the post-mortem history, which is organic remains on the land surface, and then say something about the many ideas there have been about how Lucy actually died. And you know that in modern forensics, it can be very difficult to determine cause of death. So I don't want to raise expectations at this point about being able to pronounce uncertainty, but I will give you this as an example of taphonomic thinking and how the research design can lead you to new information. So we'll start right out with where and how are Lucy's remains buried. And the possibilities that have been proposed, mudslides, and many of these are published, rapid sedimentation of flood, slow buildup of sediment, trampling, and plant growth, which you may not know much about. I'm going to include those, though. And the evidence that we have is stratigraphy, sedimentology, association with other fossils, and reference to modern analogs. So, of course, the fossil site is in the Great Rift Valley. It's very different from the cave deposits that were where taphonomy in paleoanthropology got its beginnings. And these are landscapes, and they're landscapes in a rift valley that's a very small part of the African continent, actually. And you can see the site, Lucy, it's a couple of kilometers away from AL 333, and they're pretty close in time as well. So I got to visit the site when I was out there in the early 2000s, and you've seen this image before. What I'm going to point out here, though, is that there are various topographic differences. Let's see, is this working? You can see the sandstone layers. These are fluvial deposits, that is, they were deposited by rivers, sometimes lakes and swamps. And from this kind of terrain, the geologists walk around and record the details of where the fossils were coming from. And from talking with people who were at the excavation, it's clear that the Lucy sand was a pretty distinct deposit, and even though the fossils were not actually dug out of that sand. So there was a geologist, Tesfaye Yamani, who worked in the 90s on this site and published, his dissertation actually at the University of Iowa, has a wealth of detailed information that's relevant to saying where Lucy's remains were preserved. And Chris Camposano has since visited the site. He says it's probably a crevasse splay deposit. I'm going to tell you what that is in a minute. But what's also really important here is that the Lucy sand is immediately overlain by lake deposits that had ostracods and other aquatic organisms, fish. And so by luck, this is another part of Lucy's luck, the fossils were preserved under accreting sediment that was low energy. So the Lucy site is a reconstruction, and what you see there is kind of like a black snake going through. That's the river valley, and the crevasse splays are when a levee breaks and you get a sudden flux of sediment out onto the floodplain. And actually, in the Awash River floodplain, walking around with Raymond Bonfils here, we found a place where the levee had broken. You can see the sand had flooded through the terrain and covered up a lot of the vegetation as well as possibly bones that were there then. But also I wanted to show you this from the Lake Turkana and a crevasse splay from a channel. And this is very seasonal, of course. It's the flood time that the levee breaks and the new channels are created. And so this might have been something like the site where Lucy's remains were buried. And if you think of it then through the non-flood times, these could be places where there were trees growing fairly close to the lake or not, depending on how alkaline the lake is, and swamps, wetlands, and muddy flats. And that's the kind of place that I've studied in southern Kenya in Amboseli Park, where it's very clear that the bones in these situations, even this is almost an entire skeleton of a buffalo, can form these clusters and be trampled on, and you can just imagine the plant growth and the trampling being very important in well-populated areas of floodplains and lake margins in the past. So there's actually a lot of potential to do more study of this kind of taphonomy. Okay, so then what happened to Lucy's body between death and burial? Possibilities: scavenging, defleshed by invertebrates, and I've been learning about what safari ants can do to freshly dead chimpanzee bodies in forest environments. It's pretty impressive. Submerged in water, transported by water, maybe as a whole carcass, as possibly the Turkana boy was before it ran aground and was finally buried. And again, trampling can be a major effect. So I'm just going to jump right to the evidence. I don't have time to go through all this, but what we see in Lucy's skeleton, there definitely are a number of missing skeletal parts, more than half for sure. One or two tooth marks, which I have not had an opportunity to examine myself, but the early people who looked at it, including Don, carefully looked for these kinds of features, and the bones are actually in really good condition, the parts that are there. Not much evidence of that. But there are broken parts, there are fractures, there's crushing, cracking, some of that likely from post-burial long time in the rocks. But there's no evidence really of abrasion or of weathering, what I would call pre-depositional weathering. Termite damage turns out to be really common in Ambacelli and other places, and we're beginning to recognize it in fossils. And in places where there's a lot of woodland, you might expect a lot of termites. Then why they chew bones, you'd have to ask them, but they do it. They destroy a lot. Chewing by rodents, we don't see evidence of dissolution, such as would happen in acid water, we don't see either. Now, we're with Brianna Pobiner and with the sponsorship of the Leakey Foundation, I'm hard at work establishing taphonomic reference collections so that there will be the opportunity for people in different museums to have known documentation of different taphonomic features that could give clues about the trace fossils, basically, that's what they are, that can tell you more about what happened to the skeletons before they were finally buried. And this is just a quick look at a bunch of them, including, you see, the crocodile tooth marks. But those are the kinds of things that, for the most part, we did not find anywhere on the preserved Lucy skeleton. So here's a graph showing the body parts, the skeletal parts that are there versus those that are missing compared with a whole skeleton. The gray bars are the whole skeleton, so this is just in 4 major body parts. And you can see that the appendicular bones, including a lot of the hand and foot bones, of course, are underrepresented, and the axial, in this case, somewhat overrepresented in this skeleton. And I'm going to show you a few more graphs illustrating what comparative taphonomy can tell us based on this, which is good solid evidence from the parts that we have in the museum. So here's a skeleton of a yellow baboon from Ambacelli that was a known study animal from Gene Altman's group of baboon studies there for many, many years. And we found the body a year after the animal went missing in a woodland environment, and we carefully documented it, and it was particularly interesting because it had almost a complete vertebral column. Notice it was also partly buried in the litter of that woodland soil, and parts of the skull, you can see the breakage of the cranium, which is maybe reminiscent of something we've been seeing through other talks of Lucy. That would have been from trampling. There wasn't any evidence of chewing on the skull, but the jaw's complete, the maxilla, and notice also the lack of the lower limb bones. Well, they get taken away by scavengers very easily. So again, appendicular bones underrepresented. So what caused Lucy's death? Possibilities that have been proposed. Flash flood or mudslide. Predator attack, mammalian carnivore, or crocodile, fall from a tree. Disease, other things that we can't really ever hope to test. This was an image put together by National Geographic to explain the 333 assemblage of lots of hominids. It could also apply to Lucy, of course, but there's no geological evidence for that whatsoever in either site. And, of course, crocodiles are a possibility, but they usually leave more marks and do different kinds of deletion of skeletal parts. However, there were 3 very large cats, saber-tooths at that time. There were a couple of hyenas, and there were some smaller carnivores that are known. So the possibility of ambush by a large felid predator is a viable hypothesis. But on the other hand, there's evidence from modern felids, this was an experiment by Bob Brain, that they are capable of chewing up the vertebral column very thoroughly, and they leave the limbs. So that doesn't quite fit the pattern. Notice the difference between the ungulate, where the vertebral column is much harder for a scavenger to take care of. So then what about the fall from a tree? Well, this was very elaborately published and talked about, and I haven't been party to this controversy at all. Each one of the images on this is a double of the bones of Lucy, showing in red the crushing marks. There is compressive fracturing, and it's interesting. It's not something that people who've seen a lot of fossils are particularly surprised by, because there are lots of processes that can cause these post-burial, and even by trampling. But I also just wanted to maybe reveal my feeling here about the idea that you would incur all those kinds of fractures and crushings from a fall from a tree, maybe if it were on concrete, but I don't think Lucy fell onto concrete. Most woodlands have a lot of bushes and shrubs and softer substrate under them, and lots of other ways to prevent that kind of fatal fall. So just quickly, a little bit now about 333. It's an amazing assemblage. We've heard quite a bit about it. We've seen images of these. And I was working with Bill and with Elizabeth several years in the late 2000s and with the specimens to come up with the minimum numbers of individuals, which of course their expertise was crucial. And this is what we have, and it's not published yet, and that's why I don't want to talk very much more about 333. But it's a fascinating, continuing taphonomic puzzle that I hope to get back to very soon. So this is what that skeletal part preservation looks like in the same kind of graph. And you notice that the axial elements are very underrepresented, which is a little bit like what Bob Brain found that cheetahs do to baboons. There may be other reasons why vertebrae are rare, but it's actually, and then when you line them up, it's quite strikingly different from what we see with Lucy. And this one taphonomic character that needs to be added to a lot of other evidence before we come up with final conclusions. So just now a summary. Sorry, this got a little reformatted for me. But the burial, I don't think, mudslide is out of the question. Slow buildup of sediment would not have preserved the bones as well. Transport by water, the skeleton itself was not sorted or transported. And the flood or mudslide, cause of death. So I think our process of thinking can eliminate some of these and then highlight some that are pretty clearly possibilities and viable hypotheses. I think the fall from a tree, there's more work that could be done to possibly eliminate that as an option, but it's worth considering. It's worth being part of the debate. And the mammalian carnivore, if we do more work with modern analogs and the kinds of evidence that Lucy provides compared to what's out there in modern systems, we may be able to throw more weight onto that. And we'll never know about other possible causes of death. So the legacy for taphonomy in paleoecology, Lucy's helped to stimulate so much thinking about how animals die. Our curiosity about how she died has extended much more broadly to see what we can do with this kind of evidence where there are no witnesses. And it also gives us some pause about going too far in interpreting some of these things that we'd like to know, but we really don't have the evidence for. And the comparative taphonomic research, I think, can now be a new area to focus on, and pinpointing the cause of death will remain elusive as it is for our own time. Thank you so much for being part of this, and especially to Don and Bill and Elizabeth and the Institute of Human Origins for everything they're doing, and also Lucy, as others have thanked, for helping to make my career, actually.